Hello guys, welcome back to my channel. As we have discussed in the previous class, we have completed the introduction, theory and last. If you have not visited that video, you can just see it is uploaded in my channel in the playlist. You can check it. Today we are going to complete the instrumentation associated with the UV spectroscopy, UV visible spectroscopy, and in the next video we are going to complete the UV visual spectroscopy. Today the instrumentation involved in UV visible spectroscopy we are going to study. This is the instrumentation. It is made up of firstly the light source, filters and monochromators, sample cell, detectors and readout devices. Here you can see the diagram. The source where the radiation or electromagnetic radiation falls on the prism where it disperses, and these two are used to select the beam of light, and he's a sample holder, or it is also called as cuvette, and the detector. Here is the actual representation. You can draw any of these two diagrams. It is both are same, but here we have taken the prism. This is the monochromator. Actually monochromator is this one. It is one detailed image, that's it. The sample, the lens, mirror, slit, prism, filter and grafting, we use only any of these one. And sample holder, detector and readout devices, it measures the signal, how much of the absorption or emission of the light by the sample is done, that's it. Detector detects the light output. Firstly, did you understand, I think you have understood the instrumentation. It consists of a light source, a filter and monochromator, a sample cell, detectors and readout devices. We'll go through one by one each. First, the light source. What is firstly light source? A light source gives the required light, and at and required range. The light source depends upon the what is the spectroscopy. If we are using UV spectroscopy, then the range should be in UV and visible range, like 200 to 800 nanometer. It is a UV range, so that we select the sample based on that detection. We select organic aromatic compounds or organic compounds likewise. Then what are the ideal characteristics of the light source? It should be stable, do not fluctuate, economical, should emit and continuous spectrum. It should be simple in construction and operation. Here the ideal properties are: it should be stable and do not fluctuate. Do not fluctuate means it should send the same amount of light, and continuous spectrum. You should not stop the light at for a second or for a millisecond also. It should continuously emit the same radiation what it has been emitting from the start. And it should be economical. It should not be like, it should be high, it should be like very high cost. It should be like a minimal budget, and it should emit continuous spectrum. That's what I have told. And it should be simple in construction and operation. It should not be complex. It should be in an operated, it should be an like easy way where anyone can operate, anyone can start this instrument. It should be in such a way that there are many types of light sources, or many different types. First one is hydrogen discharge lamp, deuterium lamp, xenon arc lamp, and tungsten halogen. In exam, you can explain any one of them. Any one is enough, more than enough. I will explain any two. If you want, you can refer the online or any other sources. I will explain three of the detectors. In hydrogen discharge lamp, in an hydrogen discharge lamp, a pair of electrons is enclosed in a glass tube filled with hydrogen gas. When the current passes through these electrodes, maintained at high voltage, discharge of electrons occurs. This excites hydrogen molecule, which in turn causes emission of UV radiation in in near UV region. They are stable and robust. Robust is means strong, steady, able to withstand difficult conditions. This is about hydrogen discharge lamp. Huh. I'll explain you by using a simple diagram. You can just understand very easily. In this diagram, a high voltage is supplied, high voltage current is supplied to these two electrode. Here, when the high voltage or high current is passed through these electrodes, the electrons are released outside. These electrons in turn causes excitation of the hydrogen molecule. This hydrogen molecule, after excitation, it produces the UV light. This is the basic principle of UV of hydrogen discharge lamp. As I said, it contains a pair of electrodes is enclosed in a glass tube filled with hydrogen gas. When the current is passed, these electrons maintained at high velocity discharge electrons occurs, which excites the hydrogen molecule, as I said, which in turn causes emission of UV radiation at near air. That's the main thing of the UV discharge lamp. Next, xenon arc lamp. A xenon arc lamp is a specialized type of discharge lamp. Light produced by passing electricity through ionized xenon gas at high pressure, and the wavelength range is 200 to 1000 nanometer. It is UV region. Tungsten, another one is tungsten halogen lamp. Its construction is similar to a household lamp. You have many people have seen in late before these LED bulbs, we were using tungsten halogen lamp in household, which produces yellow color light. The same principle here is used in this light source also. The bulb contain a filament of tungsten fixed in an evacuated condition, an empty space, and then filled with an inert gas. Evacuated condition refers to the empty space in the lamp, and it is filled with inert gas. The filament of tungsten can be heated up to 3000 degrees. Beyond this, tungsten starts sublimating. It is used when polychromatic light is required. The tungsten halogen lamp is used only when polychromatic light is used. It produces multiple chromatic light. All the ranges, all the UV regions it covers, so it's called a polychromatic light. Demerits is it emits the major portion of its radiant energy near IR region of the spectroscopy. The major demerit is that the light produced by the tungsten halogen lamp is at near IR region. That's why it is the demerit of this tungsten halogen lamp. Next, we are going through the filters or the monochromators. We can go through another detector. This is also one important detector, deuterium lamp. It is similar to the hydrogen discharge lamp, but it is filled with a deuterium in place of hydrogen. As I said, it is also similar with the hydrogen lamp, and the gas is filled with deuterium. That's replaces the hydrogen. That's it. It offers 3 to 5 times more intensity than other types. Deuterium lamp is the most expensive than hydrogen lamp, but it is used when higher intensity is required. It is like more sufficient, more expensive, but it is used when higher intensity is required. These are the different types of light source. Next, we are going through the monochromators and the filters. Guys, you may feel this video is lengthy or it's going lengthy. I'm explaining slow because if you study this UV spectroscopy, right, you may cover almost every instrumentation, because the detectors, the monochromators, the lens, and the types of monochromator used are similar in other instrumentation. If you study, like if you keep your mind in this particular topic and understand carefully, right, next topic, like it will be like more easier, you can understand it very quickly. And I will also not explain this monochromators or colligating system in the next upcoming instrumentation, so that this time for this uh, video you should be very careful and understand very you should focus. That's it, you should focus on this topic. Next is colligating system. The radiation, it is also it's called as monochromators or filters, all comes under collimating system. The radiation emitted by the source is collimated, made parallel by the lens, mirror, and slit. Lenses, mirrors, and the slits. First, we'll go through the lenses. Materials used for the lens must be transparent. As you all know, it should be transparent for to the radiation. Ordinary silicate glass transmits between 350 to 3000 nanometer, and is suitable for visible and near IR regions. As I said, it is between the silicate glass is used between transmits between 350 to 3000 nanometer, and it is very suitable for visible and near IR regions. Quartz or fused silica is used as a material for lenses to work below 300 nanometer. If we want more than 300, then we use silicate glass. If you want less than 300, then we use quartz or fused silica. That's it. Next, mirrors. You know, right, lenses, they focus the light. It'll be like this. Mirrors. Next is mirrors. These are used to reflect, focus, or collimate light of beam in spectrophotometer. To minimize the light loss, mirrors are illuminated on their front surface. Mirrors, right? You know, mirrors, they reflect, they focus, and collimate a light beam in an spectrophotometer. Then to reduce the light loss, we polish, we apply the we apply aluminium we coat with the aluminium on the front surface of the mirrors to minimize the loss of the light. Next, slits. It is an important device in resolving polychromatic radiation into monochromatic radiation. Here the main function of slit is, it is very important. It plays a very important function in conversion of polychromatic light to the monochromatic light or radiation. To achieve this, entrance slit and exit slit are used. The width of the slit plays an important role in resolution of polychromatic light. Here the width is nothing but the distance between the upper and the lower. This is called width. This plays a major role in conversion of polychromatic light into monochromatic light. Okay, it contains two slits. One is entrance and one is exit. When the light passes here, and the required amount of monochromatic light goes through the sample. That's it. That's the function of slit. We'll go through one by one. First, monochromators. Colligating system is just introduction of the lens, mirror, and slits. In that, monochromators, it is a device used to isolate the radiation of a desired wavelength from wavelength of continuous spectrum. Continuous spectrum is nothing but polychromatic light. Selection of desired wavelength from polychromatic light or wavelength of continuous spectrum. That's it. These are the devices which convert a polychromatic light to the monochromatic light, as I said in first. That's it. the components, or the like what are the all the components used in uh, the conversion of polychromatic light to the monochromatic light. First, entrance slit. Already we discussed about this entrance slit. Collimating device, it should be lens or mirror. Next, dispersion device. Next, exit slit. These are the four types. First, entrance slit, through which polychromatic radiation enters from the source. Next, collimating system. Here we use either the lens or the mirror. Next, dispersion. Dispersion element disperses the heterochromatic radiation into a component wavelength. Here the light, as a single light passes, it disperses the light into different wavelengths, component wavelengths. Next, exit slit allows the nominal wavelength together with a bond of wavelength on either side of it. It allows only the required wavelength to pass. Exit slit allows only the required radiation to pass through it. Here is the diagram of it. Here is a rough diagram of representation of the total what is the process. First, it is the entrance slit and it is the exit slit. Here, as the polychromatic light passes through the entrance slit, here mirrors are used to reflect or diverge the light rays on the type grafting, diffraction grafting. Here on diffraction grafting, the required length, polychromatic light is converted into monochromatic light, and the monochromatic light passes through the focusing mirrors, and then it is passed through the exit slit. The required length, the required wavelength is passes through the exit slit. Here, after exit slit, the sample. Next, we'll discuss about the in detail what are the different types of monochromators used. One, the filters, prism, and grafting. These are three types of monochromators used in the instrumentation. Next, firstly, we'll discuss about the filters. There are two types of filters used. First one is absorption filter. Absorption filter produced in a variety of host materials like gelatin, liquids, or plastic. These are the materials used for preparation of the absorption filters. Next, the basic principle of absorption filter is that it works by selectively absorption of unwanted radiation. It absorbs the unwanted radiation, means it does not allow to pass through the filter the unwanted radiation. It only transmits or passes the required radiation. Works by selectively absorption of unwanted radiation and transmits the radiation which is required. That's it, the basic principle. And selection of absorption filter is done according to the following procedure. This is the filter. First, draw a filter wheel. This is the filter wheel. You should draw the filter wheel first. Next, write the color VIBGR in clockwise or anti-clockwise manner. Have taken a clockwise direction, so VIBJYOR. You know, right? VIBGR. It is the color indicates 7 colors of the rainbow. Next, if a solution to be analyzed is blue in color, a filter having a complementary color orange is used to analyze. If the sample solution is example blue, complementary color orange is used for the transmission of light. All the radiation will be absorbed. Only the light passes from this is transmitted. Transmitted means the required wavelength. All the other radiation will be absorbed. That's it. That's the basic principle. In absorption, glass filter is made of solid sheet of glass that has colored by pigments which is dissolved or dispersed in the glass. Next, merits. It is simple in construction, cheaper, and selection of the filter is easy. These are the merits, and this is the absorption filter. Next, we will go through the second type of filter. But sorry, we have demerits. What are the demerits? It is very less accurate. As I already said, it gives the wavelength based on the range. Here 580 to 620. So it is like less accuracy. Then we have measured at 400 nanometer, but we get radiation from 373 70 nanometers to 430. Hence, less accurate result are observed. Already I said it gives in the range, but not in particular wavelength. It gives at the range. As we know, we have selected based upon the ranges only. See, from here to here, it is 400 to 430. From 430 to 390. Based upon the range, the wavelength is selected. So that it is like one demerit of the filter, absorption filter. Next, interference filter works on the interference phenomenon. The main principle principle involved in this filter is interference phenomenon, causes by rejection of unwanted wavelength by selective reflection. Here you can see in the diagram. This is the diagram. First, you have just glance the diagram once. Okay. Next we'll go. It is constructed by using two parallel grasses. As I said, it is constructed by using two parallel glass, surface 1 and surface 2. Next, parallel glass plates which are silvered internally and separated by a thin film of dielectric material of different reflective index. Example, calcium fluoride, SiO, magnesium fluoride, etc. These filters having a band pass of 10 to 50 nanometer with peak transmission of 40 to 50%. As I said, see, you can see in the diagram. The light passes. Here, the unwanted radiation is reflected back. Again, when the light beam comes, the unwanted is reflected back, and the wanted radiation passes through the surface B. That's it. This is the basic principle. Here is the principle. First reflected refraction gives monochromatic light from the slit. That's it. Here I'll explain the diagram to you. It contains the glass material. It is surface 1 and surface 2. Surface A and B are semi-transparent silvered film. It is the exit slit. You can see it is the exit slit, and here it is the entrance slit. Light beams. These are the light beam passes. By selectively interfering the unwanted radiation, the wanted radiation is transmitted. This is the basic principle of this interference filter. Next, we are going with the prism. Sorry guys, this video is a little bit lengthy. It already has crossed like 20 minutes, so that this prism and the rest of the instrumentation will be covered in the next video. Thank you guys. Please understand this topic is very important, so I'm going very slowly. From next instrumentation, I'll be like I'll cover the topic in less than 15 minutes. I will cover the 15 or 20 minutes. I'll take the topic time. For this topic, please adjust and wait, I'll show the notes for you. You can refer at the last of my video. Today we have studied, we'll just recall the full lecture. Today we have studied the instrumentation. What are the instrumentation? Light source, filters, monochromata, sample cell detectors, and this is the diagram of it, and ideal properties of the light source and types of light sources. You can pause the video and write down the notes. I will provide the notes for you for this chapter, but it takes time for creating other Telegram channel or a WhatsApp group. I will do submit these notes later. For now you can just refer it. I recommend you like first listen all the chapter, then you write down the notes, or else it will be like little bit confusing, because I have referred all the standard materials for preparing my notes, so that it's little bit lengthier, and you can skip the some parts if you don't want to write. But in exam, if they ask for 10 marks, you have to write it completely. Thank you guys. If you are seeing this video, I have already been succeeded. Please encourage me by just a comment, or just subscribe. It makes me motivated. And if you like me to improve in at a particular region, at a particular topic, if you want to tell me, you can give me suggestions. I will take any suggestions. Thank you guys. Bye. Take care. Love you.